Welcome to the Math 1 lesson summary video for the task I can see, can't you? This is a solidify understanding task, and I'm going to skip on down to problem 10 because the purpose of this task is to introduce the concept of average rate of change, and that is most easily and most efficiently done here through problem 10 through 14 based off of this graph. So in problems 1 through 9, you would have been looking at a real-world scenario of a home and its value increasing over time, and you would have found in problem 9 a formula for average rate of change. And that formula for average rate of change is if I have an interval from A to B and I want to know the average rate of change over that interval, well, then I have to find the change in y, which is f of b minus f of a, divided by the change in x, which is b minus a. And so that's one way that you'll see the formula written. Another way you could think of it is if I have 2 points, x1, y1, and x2, y2, well then this formula could be simplified to be y2 minus y1 divided by x2 minus x1. So either of these are ways of determining the average rate of change, or the AROC, as some people like to call it, if you want to be cool in math world. So first off, we have to think of an equation of this graph shown here, and it's an exponential function, so we're looking for something of the form a times b to the x power. It's starting at 1, so I know it's going to be y equals 1 times something to the x power. So it's going from 1, and then down here this looks like maybe 1 comma 1 half. So we had 0, 1, then we had 1 comma 1 half. If I go backwards, I have negative 1 comma 2. So thinking about what could I multiply that's going to take me from 2 down to 1 and then 1 down to 1 half, well, that's 1 half to the x power. So most simply we can write this equation as y equals 1 half to the x power. And that's important. That allows us to answer questions like what we're going to be answering in number 11. So to answer question 11, we have to find the average rate of change of this function from x equals negative 3 to 1. So we need to first find the coordinates of this point here at negative 3, and that's negative 3 comma 8. So in other words, if I want to use the first formula, f of b, well, f of negative 3 is 8. I'm sorry, that's f of a, and this is a, and this is b. And then so f of b, f of 1, is 1 half. So to find the average rate of change, we would be looking at 1 half minus 8 divided by 1 minus negative 3. And so 1 half minus 8, or 0.5 minus 8, is negative 7.5. And negative 7.5 divided by 1 minus negative 3 is the same as 1 plus 3, which is 4. And so if I round that to the nearest thousandth, I'm going to get 1.875, and that's not actually rounded, that's an exact value. All right, and so we can go on to the next question. All right, so this one's saying, what is the average rate of change? Again, the same keyword, on the interval x equals negative 3 to x equals 0. So again, this is going to be a, this is going to be b. So f of negative 3 we already know is 8, and f of 0 is 1. So this time we're looking at f of b, which is 1, minus 8 divided by 0 minus negative 3. And so that's going to be negative 7 divided by positive 3, because minus and minus becomes plus. And so rounding that, that's approximately negative 2.33. And I just realized on the last problem, I forgot to include the negative on my answer. So my mistake there. Now, what I want to point out here is something that actually comes up in problem 15. And that is, if I connect the 2 points that we just used for this orange line. So we had x equals 0 to x equals negative 3. If I connect those with a line, well, what you'll find is that the average rate of change is equivalent to the slope of that line that I just drew there. And that line is called a secant line. So the average rate of change is equivalent to the secant line for that interval. And so you can see that that negative 2.33 is a steeper slope than if we look at the slope of the previous problem's line, secant line, which would have been here. And it's not as straight as I'd like it to be, but you can see that the orange line is steeper than the purple line. And negative 2.33 is bigger than negative 1.87, or it's a greater magnitude, I should say. It's actually smaller because it's in the negatives. So we can carry on practicing. Question 13 says, what is the average rate of change on the function from the interval x equals negative 3 to x equals negative 1? So now we're looking at this secant line here, so we can tell it's going to be even steeper. So let's actually use this second formula, the y2 minus y1 over x2 minus x1. So I'm going to write them as points this time. So we have the point negative 3 comma 8 and the point negative 1 comma 2. And I'm just trying to give you variety so that you can decide which way is easier for you. So this would be x1, y1, x2, y2. So to find my average rate of change, I would have 2 minus 8 divided by negative 1 minus negative 3. And so I'd get negative 6 over, this becomes addition, negative 6 over 2, which is negative 3. So it's as we predicted, even steeper. And then finally, the average rate of change on this function on the interval from negative 3 to negative 1.5. So that's going to be negative 3 comma 8 and negative 1.5 comma, I could approximate, or I could use the rule that we developed. So we know we're looking for 1/2 to the negative 1.5 power. And so if I do that calculation in my calculator, I get 2.83. And so that's negative 1.5 comma 2.83. So then again, I have x1, y1, x2, y2. So to find the average rate of change, I'm looking at 2.83 minus 8 divided by negative 1.5 minus negative 3. So in the denominator, because that becomes addition, I know that's going to be 1.5. And in the numerator, that's going to be negative 5.17. So when I divide, that is approximately negative 3.45. So you can see that's going to be even the steepest line, and I can barely fit it in there. And you can see that. All right, thanks for watching. If you need help with the Ready, Set, Go problems that are aligned with this lesson, then check out the Canvas student support site, Ready, Set, Go aligned homework videos.